ಇದು ಬೆಟರ್ ಲ್ಯಾಪ್ಟಾಪ್ ಅನ್ಸುತ್ತೆ, ಯಾಕಂದ್ರೆ ಇದು ಬೋರ್ಡ್ ಕಾಣಿಸಲ್ಲ.
ಬೋರ್ಡ್ ಕಾಣುತ್ತಲ್ಲ.
ಓಕೆ,
ಅದೇ ಎಲ್ಲ ಕಾಣುತ್ತೆ, ನೀವು ಅಷ್ಟೇ ಲಿವಿಂಗ್
Good afternoon. How have you had lunch? Can you see the board? ಕಾಣಿಸ್ತಿದೆಯಾ? ಅಂದ್ರೆ reflection ಆಗ್ತದೆ. ಎಲ್ಲಿ ಸ್ಟಾಪ್ ಮಾಡಿದ್ವಿ? Geomorphology we have completed more or less. Landforms will do. Climate. In climatology, there is one basic phenomena, right? If you know that everything is built upon that. If you study, I mean, you can study cyclones, or you can study currents. I mean, even in oceanography, you consider any part. It is built upon this basic understanding. The basic understanding would be related to development of high pressure and low pressure, and the wind movement, and one circulation. And another thing is with respect to that, we'll also understand different types of winds, global circulation. Once if you understand that, that will be helpful in understanding many other things, including Indian geography, like monsoon also. So this chapter is important for understanding Indian monsoon also, from the perspective of Indian geography also. So I will take some random topic. I will discuss what is it actually. Think. This is Earth's surface. Earth does not heat up equally. Longitude, latitude in a yes. So I should cover that also. So we'll cover that. Latitude and longitudes. Latitudes and longitudes. So everybody have the basic. So latitude, longitude. So what are latitudes? These are both are imaginary lines, right? So basically we can say they are horizontal lines. For your understanding, we say they are horizontal lines on the surface. So why they are drawn? Basically to determining a location. Earth is spherical, so in sphere you cannot locate a position very easy, right? You cannot say right, wrong, up, and there is nothing like that. It is one complete sphere. So in order to determine the location, we need these latitude and longitudes. The place where they meet, that is called coordinates. We find coordinates, right? For example, for Delhi, it's for Bangalore, it is 13, right? So Indian longitudinal extents also, 8 degree to 37 degree, right? And latitudinal extent, longitudinal extent 67 degree to 68 degree to 97 degree. So the extent, right? So with this, we are understanding the location where India is located, eastern part of the longitudes, like that, basically to determine the location. And so a point where both of them meet up, okay, we determine it by coordinates. Coordinates means we we write down the latitudes and the longitudes of that particular place. Wherever those two lines meet, that is the exact location. Okay. So first, let us take up latitudes. Latitudes are horizontal lines, right? So they're imaginary lines. They're drawn horizontally. Important latitudes include 0 degree. 0 degree is for equator. So tell me important latitudes. 23.5 degree. North. This is called Tropic of Cancer. Tropic of Cancer. And here 23.5 degrees south. This is called Tropic of Capricorn. And 66.5 degrees. This is called Arctic Circle. Arctic Circle. And this is 66.5 degree. What is this called? Everybody should be thorough with this. The north and south. Antarctic Circle and Antarctic Circle. And there is 90 degree. south and 90 degree. 90. So you are measuring this in terms of degrees. How we are measuring in terms of degrees? For measuring any circle or any sphere, when you measure, you have a reference point. What is the reference point for measuring latitudes? From where do we measure? This is 0 degree from where? The center of the earth. Okay, central point we consider. So from center, at what, how much degree it is deviated from the center? 1 degree, 2 degree, 23.5 degree, 24, 25, 66. This is 90 degree. Correct? So what is the reference point here? So remember that latitudes are measured from the center of the earth. Even longitudes are also measured from the center of the earth. We will come to that later on. Okay. So important latitudes include this. And due to latitudes, we divide, based on the latitudes, we divide earth into different heat zones. Okay, that also you know. From 0 degree to 23.5 degree north and south, this is called Tropic of Cancer. Why it is called Tropic of Cancer? Because here sunlight is high. First of all, temperature is high here. And one more technical definition is in 1 year, at least once, sun rays will be directly overhead. Exact time at mid-noon. Right? Sun rays will be exactly overhead in these regions. At least once in a year. Okay. So these topics are important. It takes some time to. I think today we cannot finish. We cannot finish whole of geography. It's not possible. Because many important topics are left behind. We'll see. First, let us focus here. So, what is this? This is a tropical zone. So, where sun rays will be directly overhead at least once in a year. This is next zone is temperate zone between 23 and up to 60. Where sun rays will not be directly falling. There will be slanted sun rays. And this is what rigid zone, where temperature is very less. Correct? Direct sun rays, will not reach an entire. The temperature is very less. So, three heat zones are tropical. It's also called torrid. Second one is what? Temperate. And third one is frigid zone. Understood? So, three heat zones, tropical zones, temperate zones, and frigid zones. Okay. And these two are called polar circles. Arctic circle and the Antarctic circle. Okay. So, and equator divides Earth into two halves, two hemispheres. What are they? Northern hemisphere and the southern hemisphere. Correct? Everybody knows this. Next, let us take up latitudes. Latitude means what? So longitudes. Longitudes are lines joining two poles, right? And these are lines which are joining two poles and they are merging at the pole. So they are like vertical lines. They are also imaginary lines. So what is the main purpose of longitude? Determining time. Main purpose of longitude determining. Together, the purpose is to determine the location. Individually, for longitude, the main purpose is to determine the time. Not only time, determine the time, not only the time, but also date. Time and date. How do you measure longitudes? So there are how many longitudes? How many longitudes? From 0 degree, 180 to the east and 180 degrees to the west, east and west. 0 degree. Right. So 0 degree passes through which countries? 5 countries it passes through. Not 5 countries. Many countries are there. Not more than 5. UK, France, Spain, Algeria, Mali, Burkina Faso, Ghana and Togo. Okay, Ghana and Togo. So these are the countries through which 0 degree passes through. This 0 degree is called prime meridian. Prime meridians. Okay, so there are how many prime meridian, how many meridians or how many longitudes? From which side 180? This side 180. How many? 360. 0 degree. Simple question. How many longitudes are there? How many longitudes are there? 361. 361. Like, as per this understanding, it should be 361 because 180 and 0 degree. But point here is these 180 degrees is only one because both of them meet. You are imagining in a two-dimensional scale, right? Imagine a three-dimensional arc where 180 degree meet, right? So there is only one 180 degree. Both east and west merge. So there is only 180 degrees. So that's why 360 longitudes are there from 0 degree this side and that side. Okay. So how many latitudes are there? How many latitudes? Latitudes. 0 degree, 90, this side 90, right? Here is 181. This side 90, this side 90. And here 90, 90 are separate. Unlike longitudes, where they meet, right? There is only 180 degree. Here two 90 degree latitudes are there. So there should be how many latitudes? 180.
Including the equator, it should be
Also called
182.
parallels. Okay, longitudes are also called meridians. Remember, longitudes are also called meridian, like prime meridian, 0 degree meridian, right? So similarly, latitudes are also called parallels. Parallels. If they ask how many parallels are there, it should be 179. Answer is 179. Why? Because parallel means there should be a line. There should be a line. Right or wrong? There should be a line. So 0 degree up to 89 degree, no problem. All of them are have some length. But 90 degree is just a point. It is not a parallel. It's a latitude. No doubt in that. It's a 90 degree latitude, but it's not a parallel. Understand this? So remaining latitudes are parallels. So that's why we have to divide these two latitudes in order to count the parallels. Parallels are 179. So they might confuse here. So focus here. So we were discussing what longitudes. So there are 360 longitudes, right? So one circle 360 degree. All of you know that. So Earth rotates 360 degree in how many hours? Earth rotates 360 degree in how many hours? 24 hours, right? 24 hours. Earth rotates 360 degree in 24 hours. So 24 hours equals to 360 degrees. So 1 hour equals to 24 ones are 15. I mean 24 15 are 360. Right? So 1 hour equals to 15 degrees. Always remember this date is important. For 1 hour, Earth rotates 15 degree. Another 2 hours it rotates another 15 degree, 30 degree, like that. Correct? So to rotate complete 360 degree Earth takes 24 hours. Understanding? Everybody know this? So 1 hour equals to 60 minutes. Correct? 60 minutes is equal to 15 degree. Next, 15 ones are 15 fours are. So 4 minutes equals to 1 degree. To rotate 1 degree Earth takes 1 minute. To rotate 15 degree Earth takes 1 hour, 60 minutes. Okay. Then Pirutha, because I will ask questions later on this. So always just take these two things. 1 hour equals to 15 degree. At least this you should remember. You can arrive at it later. Okay. Even if you do not remember, just you calculate, it will arrive. Okay. So this 0 degree here, it passes through a place called Greenwich near UK, in near London in UK. Okay. So there is Royal Astronomical Observatory located in London, near London in UK. So that has been considered the line which passes through that place is by convention, by agreement, considered as 0 degree or prime meridian. Okay. So that was determined in 1884. Okay, so we have to, among these 360 lines, we have to take at least one line as standard line. From there, we can refer east or west. Correct? So, prime meridian divides Earth into two hemispheres, just like equator. Equator divides Earth into two hemispheres, northern and southern. Similarly, prime meridian divides Earth into eastern hemisphere and western hemisphere. That is why India's and other countries are called eastern world, eastern countries, right? That is western world, right? Okay. Okay, from here, from 0 degree, if you come this side, Earth rotates west to east. Everybody know that Earth rotates from west to east. Like that, Earth is rotating. Correct? So, which regions receive sunlight, sunrise for the first time? Japan. I mean, that's the first major country. I'm asking eastern countries or western countries. Eastern. This hemisphere receives sunlight first. then Earth rotates, this region will get exposed to the sun. Earth is rotating from west to east. Correct? Understand this? Assume sun is here. First sunlight will be this side. So these countries, first sunrise will happen in Japan, for example. Then towards rest of the China, Russia, then Southeast Asia, then it comes to India. India, then northeast first, then other parts of the country, then West Asia, then Europe, then America. Sunrise will happen like this. So who are ahead in time? We are ahead in time. We are ahead in time. That means Eastern Hemisphere is ahead in time. So it should be positive, right? I mean I use plus. Here I use minus. So assume time is here 12 p.m. Okay, not mid noon. So India is located where? Here, correct? From 0 degree. So there is one line from 0 degree, 1, 2, 3, 4, here 68 degree. India starts from 68 degree and ends at 97 degree. Roughly some 30 degree difference is there, roughly. Okay. So and there is middle line is 82.5 degree. This we have considered as our standard meridian. This we use to determine our time. So there is only one time zone for India, that is Indian Standard Time, right? So it passes through this here, Mirzapur, UP. It passes through 5 states. Which are those? UP, Madhya Pradesh, Chhattisgarh, Odisha, and Andhra. 5 states. Remember always. Okay. Really. Uttar Pradesh, Madhya Pradesh, Chhattisgarh, Odisha, and Andhra Pradesh. Those 5. So this line is what? 82.5. 82.5 degree. This is passing through middle of the India. Correct? So we have to consider this as a, I mean, the time which is happening on this meridian is considered as standard time for all of the country, right? So what is the time difference between this and this? So whatever the time is happening at the 0 degree, that is called UTC, Universal Coordinated Time. Okay, so UTC, or it's also called Global Mean Time something, right? GMT. So GMT or UTC. UTC is standardly used, right? Universal Coordinated. So this is like global time because this is the standard time for the entire world. Comparing this on, I mean, we always compare time for different countries by referring to this standard time, which is exactly on the 0 degree. Understanding? So what is the time difference between 0 degree and 8.5 degree? So earlier you know that for 15 degrees 1 hour difference is there. Correct? This is 82.5 degree. So calculate it. For 15 degree 1 hour, 30 degree 2 hours, 60 degree 4 hours, 75 degree 5 hours, and 7.5 means half an hour. So how many hours? 5 hours 30 minutes. So what is the time difference? 5 hours and 30 minutes. This is the time difference between UTC and IST, Indian Standard Time. Correct? Okay. So what happens? So what is happening here is we are ahead in time. If it is 12, what will be time here? 5:30 PM or AM? PM. So we are ahead. Always remember, because we are in the Eastern Hemisphere. Countries in the Western Hemisphere will be behind this time. There will be morning. Here we are in the evening, right? There will be, so this side they will be in the morning, because time here we can say time here they are backwards. For example, take 30 degree here. What will be the time here? This is rest. 2 hours less. That means 10 AM. If it is 12 PM here, it will be 10 AM morning. Everybody knows this. Okay. So have you understood this? Next, let us take up 180 degree. 180 degree is a common line, right? There is only one 180 degree line from 0 degree. So here also 180 degree, here also 180 degree. Both of them actually meet at one point. So I am taking 180 degree as a central point. Regarding 180 degree, just understand few things. 180 degree is not a straight line. It is not a straight line, remember. It is passing through Pacific Ocean. Which ocean? Pacific Ocean, which is between Asia and North America, and Australia and here South America. So again, Australia, again you can consider Asia also. So this is Pacific Ocean. So from which ocean this 180 degree line passes through? Pacific Ocean. So exactly you can remember there is one important strait here. That is called Bering Strait. Bering Strait. So 180 degree passes through. This is one of the important GK question. In different exams, they ask the same question. What is this? Bering Strait. I mean, 180-degree passes through Bering Strait. Bering Strait is between. So this is Russia, right? And this is North America. This is North America. Here USA part, Alaska, and it is Russia. So this is what strait Jalasandhi in Kannada we say, right? So strait which connects Arctic Ocean and the Pacific Ocean. So this is called Bering Strait. Bering Strait. So 180-degree passes through Bering Strait, right? It is not a straight line. Here it deviates like this. Why it's a zigzag line? Why it is a zigzag line? Because 180-degree is also called international date line. Always remember, 180-degree line is also called international date line. This is used to determine the date. Okay, rest of the longitudes are used to determine the time. 180-degree is special because it is used to determine the date. Okay, so what happens here is the time, the date here divides. If it is what's the date today?
6th June.
6, right? So it is 6th this side. This side it will be what? 6 or 7? They are, tell me this. They are behind in time, right? So
The Alaskan side will be 1 day less.
so 5th, right? So here date is changing. Exactly, date is changing. If you just cross it, date will change. Time will be same, exactly same. Time will be exactly same. If it is 12, whatever time it is there, same time will be there on across this line. But the date will change. Understanding this? Okay. So that's why it is called international date line. And I also told you that this is western region. From 0-degree, this is western region. This is eastern region. Correct? So if you go from eastern hemisphere to western hemisphere, what happens? In the eastern hemisphere, remember, eastern hemisphere, here a lot of confusion happens always. This is eastern hemisphere, right or wrong? Do you agree with me? It is eastern hemisphere. This is western hemisphere. Like USA, consider it is west. Western countries are the so it is west. So when you go from eastern hemisphere to western hemisphere, time, what you are gaining or losing?
When we are moving from east to west.
Eastern hemisphere to western hemisphere. Don't say east to west. East to west is different. Actually, we are going west to east. We are gaining 1 day because 1 extra day. 5th, they have already lived here. 5th, we have already lived here, and again we are going to 5th. 1 extra day you are living, right? Here already 5th completed. You have completed 5th date of June. When you have gone here, again you are living in the 5th June. So 2 times you are living. So you are gaining 1 extra day. So always remember, if 1 day reduces, that means you are gaining a day. Extra day you are living. Correct? So and always remember what they are referring. Are they in the question? Have they given eastern hemisphere to western hemisphere or east to west? East to west is different. See, if you travel from eastern hemisphere to western hemisphere, you are traveling from east to west, not hemisphere. Just tell the direction. Sorry, west to east. West to east. This is west, right? No direction. This is west. This is east. If you just give direction, it is west to east. So when you travel from west to east, when you cross international date line from west to east, you are gaining a day. When you cross equator from east to west, what happens? You are losing a day. 5th, you are losing. You are directly entering to 6th. Understanding this? You are losing a day. One day you are losing. 5th date you are losing. You are entering into 6th day. 6th June. Understanding this? So few points about international 180-degree line is 180-degree line is also called international date line. Okay, where date changes if you cross across this. If you cross west to east, you lose or gain? Gain a day. If you cross west to east, you gain a day. If you cross east to west, you will lose a day. If you cross from western hemisphere to eastern hemisphere to western hemisphere, gain a day. Eastern hemisphere, but west to east. Right? Understanding? Yes. So that is why the country is, the line is zigzag because there are few islands here. If the line passes through middle of the islands are very small. In the same island, there can't be 2 dates. That will create a lot of hurdles in terms of administration, logistical, right? Many types of trade. So and it also hurt the sentiments of the country. In same country, there are 2 dates. right? So that's why to avoid that, there is this zigzag. So if the country chooses to be in the eastern hemisphere, it line will pass like this through that. Understood why it is zigzag? To avoid cutting across same country, same island country. Okay, hopefully all of this is clear. Next, we will study revolution and rotation. Revolution, rotation. So regarding rotation, what is rotation? Earth rotates around its own axis. Around its own axis. So first of all, you heard axis. What is axis? Axis is a line. They are called antipodal lines. They are called antipodal lines. They are lines. They are those lines which travel through the center of the earth and touch exactly opposite, diagonally opposite points. Antipodal lines means they travel through they passes through the center of the earth and they touch exactly opposite lines, right? Diagonally opposite points. So earth axis is also antipodal line, correct? Because it is touching two extreme points. This is 90-degree north latitude and 90-degree south latitude, correct? So it passing through the center. So if you take earth plane is this way. Earth plane is this entire plane. If it is sun here, sun will be somewhere here. There is orbit, right? Orbit. Earth does not wobble like this, correct? Earth it maintains its own plane. A plane alle irutte avagi. So I can say plane will be something like this. This is the plane, right? So I will draw a plane here in a line, single line, which is passing through the center of the earth like this. This is the plane of the earth. Okay. So earth does not deviate from this plane. And 90-degree line, 90-degree line to this plane is called normal line. What is this called? Normal. This is what? Plane of the earth. Correct? So this is the plane of the earth. So measure the angle for earth axis. It is from normal, it is 23.5 degree. So this is for tilting of the earth. Earth axis is tilted. Earth axis is tilted by 23.5 degree from the normal. Or else you can say 66.5 degree from the plane. Then from plane it is tilted 66.5 degree. From normal it is tilted 23.5 degree. Then Elrigo. So okay. So understood. Everybody understood what is plane. Most of the planets are located in the same plane, right? From sun. You know that. Okay. Earth. What is rotation now? Rotation is this is the axis, right? Earth moves around the own axis. As Earth rotates, that is, it moves around its own axis. That movement is called rotation. The movement of Earth around its own axis. Correct? That is called rotation. What is revolution? Revolution is movement of Earth around Sun. Around Sun. Correct? So for rotation, how much time Earth takes? 24 hours. Correct? Actually, there are some distinction. There is something called solar day, sidereal day, and lunar day. 3 types of days are there. So we will not get into that. So consider 24 hours as standard. Okay. So 23.5 hours Earth take. What for revolution Earth takes? 365 and half 1 by 4. 365 1 by 2. So we say 365. Correct. Okay. So here we also study leap year. What is leap year? So revolution, sun is here in the middle. Earth rotates one complete circulation. This is revolution. Rotation is Earth is rotating around its own axis. Rotation. Revolution means it will complete one complete circle around the sun. And the orbit here is not circle. What is it? Elliptical. All the planets are elliptical. Correct? All the planets orbits are elliptical in nature. Okay. So that is why what happens? Sometimes Earth comes very near to the sun. Sometimes it goes away from the sun. Because it's elliptical. If it is circular, the distance will be same all the time. Because it is elliptical, sometimes the distance changes. Sometimes it comes very near to the sun. Okay, what is this called? When it comes very near to the perihelion. Peri means near. Okay. This is aphelion. I don't know how will you remember it, but you remember it. Aphelion. Okay. Aphelion. Okay. So what are the changes? What are the effects of rotation? what are the effects of rotation? Rotation day and night are the main effects. Day and night. Seasons are due to rotation. It is due to revolution. Correct? Okay. So when Earth rotates, here it is sun. Half of the Earth, this is the axis, right? Axis. But there is another line here, right? So here what happens? Sunlight can reach maximum up to here, right? So here this will be day, and this side it will be night. Correct? So this is called line of illumination or circle of illumination. This is called circle of illumination. Half of the Earth will be day, and half of the Earth will be night, because this side is facing sun. This circle or this line is called what? Circle of illumination. This keeps shifting, right? Because Earth is rotating. Many places they will, every time some places are exactly entering into night and they're leaving the night like that. Understand this? So that's why this line will be, the places will change. This line will be fixed. Okay. So this is called circle of illumination, which divides day and night. Okay. So every time, even on Earth, currently there is one circle somewhere which separates day and night, and the places are shifting. Everybody know that. Okay. Yeah. So this is one of the important things, and we'll study revolution. That's more important. Revolution and tilting. So what are the effects of revolution and tilting? Seasons are created because Earth is tilted. Without, imagine Earth is not tilted. What is happening is, so for that to understand, you should understand the complete revolution. So this is very important. Listen here, Earth is here now. Earth is starting its journey from here. Correct. So you know that this is the axis, right? Everybody focus here. This is the axis. And what is this? Equator. Correct. So we'll only consider equator. This is the equator. Okay. So this is the pole, right? These are the poles. Because Earth is a little bit tilted, 23.5 degree, it is tilted. When Earth is this side, at this time, what is happening? Which side? This is northern hemisphere and southern hemisphere. So my question is, which hemisphere is receiving direct sunlight? Southern hemisphere, because it is directed towards sun. Everybody is clear with this? Okay. So that is why in southern hemisphere there is summer. In the northern hemisphere there is winter. Okay, from here, consider this is okay. At this day, what is happening here is the sun rays are directly falling on 23.5 degree south. 23.5 degree south. When sun rays are falling directly on the 23.5 degree south, that day is called, for northern hemisphere it is winter solstice. For southern hemisphere it is summer solstice. Okay, solstice. It is called solstice. Solstice means, so listen here, 0 degree is 23.5 degree north and 23.5 degree south. I told you this is the tropical region, correct? Because their temperature is high. One more technical definition that I have said is, these are the regions which receive direct sunlight at least once in a year. Right or wrong? These are the regions which receive sunlight at least once in a year. At least once in a year they receive direct sunlight. That means sun is exactly above it. Okay. So on which day? For example, in this position, sunlight are directly falling where? 23.5 degrees south. Tropic of Capricorn. Correct. So sun is here. Sunrays are directly falling here. This day is called so we always study with the from northern hemisphere perspective, because we are in the northern hemisphere. Okay. So at this day we are here. So it will be winter for us. Right. So when sun touches 23.5 degrees south or Tropic of Cancer, this day we call winter solstice. What do we call? Winter solstice. For us. But for them, it is summer solstice. Correct? Okay. Solstice means when sun touches extreme points. Because beyond this, sun rays will not go directly. Beyond this, if there is 24 degree line, there sunrays will not be direct ever. Sunrays will be direct only in between these regions. Right? Understanding this? So when sun touches extreme point, that point is called solstice. The day is called solstice day. So this will be winter solstice because we are in the northern hemisphere. Then sun rays sun cannot go beyond this. He will start coming northwards. So this is called northward march. Okay. So this day is exactly December 22nd. December 22nd, sunrays will be directly falling on Tropic of Capricorn. After that, January, February, March. On March 21st. On March 21st, sun rays are falling where? On the equator. On the equator. So when sun rays are falling directly on the equator, throughout the earth, there will be equal day and equal nights. Okay, one more thing. When sun was here, hello, are you following me or not? Everybody? Okay. When sun is in the southern hemisphere, okay, when sun has touched this extreme point, this will be summer. In summer, days are longer than night. Right or wrong? In summer, days are longer, nights are shorter. So here days are longest. Longest days you see in southern hemisphere on this day. So they are longer, and nights are shorter. But on this day, when sun rays are neither falling in the southern hemisphere nor in the northern hemisphere, they're falling on the equator. So days and nights will be equal throughout the earth. Throughout the earth, everywhere it will be same. Okay. After that, sun will shift again. He's moving north, right? He's moving north. So by March, after March, March, April, May, June. By June 21st, sunrise will be directly falling on the Tropic of Cancer. Tropic of Cancer. So on this day, we call it a summer solstice. What do we call? We call it a summer solstice. Okay. We call it a summer solstice. So here days will be fast. Days will be longer, nights are shorter in the northern hemisphere. Understanding this? Okay, come to the same revolution here. So this is December 22. December 22, there is what? Winter solstice. After that, sunrise will be falling directly on the equator. On which day? March 21st. After June 21st, sunrise will be falling on the Tropic of Cancer. Tropic of Cancer. Sun has moved here now. Tropic of Cancer. Understand? This is summer solstice. After that, what is this day? December. No. September. September 23rd. September 23rd. Again, sunrise will come back. Sun will come back, right? He will start his southern journey. Sunrise will be falling on the equator. Understanding this? Next, by December, he will reach this extreme point. So this is the movement of sun. Northern March and Southern March. These four, 1, 2, 3, and again he will come back. Understanding this? So this is the inter-revolution process. So with this, what is happening is, when sun is here, northern hemisphere, summer, southern hemisphere, winter. When sun goes here, southern hemisphere, so when earth goes here, southern hemisphere, summer, northern hemisphere, winter. So this is change in the seasons. Change in the seasons is due to revolution, first of all. And tilting is also important. If earth was not tilted, like if earth was like this, sunrays would have been falling directly on the equator and there was equal distribution. Then there would be no summer, no winter everywhere. There is same level of temperature all throughout the year. Correct? One side summer, one side winter, bartane irlilla. Understand this? So for seasons to occur, what are the two important factors? They will ask the same question. Okay, what are the factors responsible for the occurrence of seasons? Number one, tilting of the earth. Because it is tilted, some part exposes towards sun where there will be summer. When it goes on the other side, due to revolution, that part will be now facing towards sun. So this, in different months, in different seasons, different parts of the earth will be facing the sun differently. So that is why there will be change in the seasons, summer and winter. So what are the two factors? Tilting and the revolution. Have you understood all of this? Have you understood all of this, everybody? Okay. So next we will go to the other topics. So listen here, few basic understandings I will give you. So this is the earth surface. The sun, when sun rays are falling directly, this is called insolation. What is this called? Insolation. Earth heats up here. When earth heats up, correct? Sunlight with earth heats up. The atmosphere here also heats up. Atmosphere also heats up. The gases heats up. When the gases heats up, they become light and they get expanded. Understanding this? Anything if you heat up, what happens? They get expanded, right? And they become lighter. When they become lighter, they travel towards the upper atmosphere. This is called convection. So listen here, what is happening? Here the gas from here it is moving towards the upper surface, right? Upper atmosphere. Here there is deficiency of gas now. This creates low pressure. So what is happening here is sunlight is falling on this area, temperature is rising. With rising temperature, there is low pressure. Correct. In the upper atmosphere, it diverges. Okay. So when it spends sufficient time in the upper atmosphere, it cools. Correct. Once it cools, it will fall down, because if it's cooler, it is more denser. If it's more denser, its weight and mass increases. So it will be subjected to the gravity. Under gravity, it will fall down. So here it develops high pressure. So wherever there is high pressure, wind is blowing coming from top to bottom, in the sense from upper atmosphere to the lower atmosphere. So wherever there is low pressure, wind is blowing from lower atmosphere to the upper atmosphere. Do you remember this always? Okay. Now air blows from high pressure to low pressure. Correct? So can we complete the cycle like this? There is low pressure where wind is rising and it is diverging. So on both sides there is what? High pressure. Correct? Because wherever wind is falling down, there is developing high pressure. So wind blows from always high pressure to low pressure. So wind always blows from high pressure to low pressure. Correct? So the air is moving from high pressure to low pressure. The moving air is called wind. The moving air is called wind. Now apply the same concept, okay, to general atmospheric circulation. See what is happening here. Equator always receives sunlight. Why equator always receives sunlight? Because of the shape. What is the shape of the earth? Shape of the earth is called geoid. Geoid means earth is spherical, fine, but it is not a complete perfect sphere. It is not a perfect sphere. It is little bit variations are there, because near the equator it is more bulbs like this, more fat here, and near, at the poles it is flat, something like this. Okay, understand this? At the poles it is flat, and near the equator it is bulbs. Can you see this bulbs here? So if it is bulbs, wherever sun goes, sun might be here or here. This region always receives sunlight because it is bulbs. So there will be high temperature along the equator, right or wrong? Because of the shape of the earth, because it is bulb here. Okay. So see here what we were discussing. Yeah. Yeah. This region receives higher sunlight. That means temperature is always higher. And temperature always high in convection. Convection, there's low pressure, right? Tell me the cycle. Low pressure because of high temperature. Convection, divergence, and this is descent. Whenever wind is falling down, what kind of pressure should be here? High pressure. If wind is falling down, it is high pressure. Okay. So there is low pressure here. Assume there is a low pressure here. Next. So wind blows from high pressure to low pressure. When it blows from high pressure to low pressure, again it rises. At low pressure, what happens? Wind rises. Always remember, at low pressure, what happens? Wind rises, right or wrong? So your wind is rising, right? So after that, again it diverges, it falls down. Again it diverges and falls down. Correct? So here also you can see. Shall I repeat again? See here. Shall I take another color? White. Okay. Equator receives higher temperature. Temperature is high. That's why pressure is low pressure. So convection, divergence. What is this? High pressure. Here there is high pressure. So wind blows from high pressure to low pressure, right? Wind illinda correct? Because the high pressure is low pressure is correct? Are you following me? Okay. Here there is again low pressure here. It is high pressure, right? So wind blows from high pressure to low pressure. Again, wind is blowing from high pressure to low. At 90 degree also there is high pressure, because that's very cold. Wherever there is cold, that's high pressure. So wind blows from high pressure to low pressure. Right or wrong? So at low pressure, these two winds meet and they again rise. Again, it diverges, falls down like. Correct? So can you see three cycles are developing here? 1, 2, 3. These cells are forming. This cell is called Hadley cell. What is this called? Hadley. Second cell is called parent cell, and third cell is called molar cell. Okay. If you have more confusion, you can meet me after the class for this. Okay, on this. So again, same in the southern hemisphere. There is low pressure here. Correct? Same in the southern hemisphere. There is a low pressure line here. So wind blows from high pressure to low pressure, it rises and diverges. Now let us give names to this. So first, what I told you, at equator wind rises. Correct? So here low pressure develops, right? This low pressure is called ITC zone. Intertropical convergence zones. Why it is called? I will just explain. Wait. And here what is high pressure, right? This is called subtropical high pressure because this is a subtropical region. Just above Tropic of Cancer and Tropic of Capricorn, in the temperate region, there is this zone called subtropical. After tropics, okay. So there is high pressure, subtropical high pressure. This is called subtropical high pressure. Correct? Again, there is this what? Subpolar low pressure. I told you there is a low pressure here. That is subpolar low pressure, and this is polar high. Similarly, here what? Subpolar low pressure, and this is what? Polar high. Understanding this? Now I told you that wind blows from high pressure to low pressure. Correct? Wind blows from low pressure to high pressure. But mind the direction now. Now I'm drawing the direction. I'm highlighting the direction. Direction will be like this. The reason is Coriolis force. There is something called Coriolis force. That is a pseudo force which generated due to rotation of the Earth. When Earth rotates, what happens is, just imagine. Are you following me? Nobody is attending for the first time. Geography first time keltila dana. Everybody have some background, right? Okay. Not background, you have read something, right? Okay. So there is this Earth, it is rotating from west to east. When Earth is rotating, what happens is, see, just imagine there is a person here, there is another person here, it's a plate, it's a plank. These two people are playing balls. Okay. He throws a ball to this person, but this below this plank is rotating. Okay. So what is happening is, in any way it is rotating. I assume it is rotating like this person throws ball to this person. Correct? He assumed that this person is here. Okay. So he threw the ball. By the time ball reached here, this person has moved to this position. Right or wrong? Because this below plank is rotating. Ball he has thrown. But by the time ball has reached from ball should reach from here to here, the below plank, the position of the person has changed from here to here. Because below plank is rotating. I understood? So for this person, how it appears? It appears like the ball is drifting away. It is changing its direction. Correct? It was coming towards him. But now it has gone there because he himself has shifted. Understanding this? So here at least knows that below plank is rotating. But on Earth, we do not feel that Earth is rotating. For us, it appears like it is the wind itself. I mean, whatever the object that is coming towards me, that itself is changing the direction. The change in the direction is because of rotation of the Earth. Here in this case, in this example, it is plank. So assume instead of plank, assume it is a Earth. Earth is rotating. That's why whatever the object it moves, it appears like it is changing a direction. So there is this change in direction due to what force? Coriolis force. And this Coriolis force deflects moving objects towards right in the northern hemisphere. Always remember, if any object is moving like this, what is right to this? This. This is Coriolis force. In the southern hemisphere, it is left. Okay. In the southern hemisphere, it is left. So now we can see there is this change in direction. Here, southern hemisphere, it is because of Coriolis force. Okay, please mind it. You can go and revise again. So this Coriolis force and direction, you can again determine it. And again, these are what? Now let us name the winds. These winds at the tropics are called trade winds. These are called trade winds. These are called westerlies, and these are called polar easterlies. Polar easterlies. So this is called general atmospheric circulation. These are called permanent winds. There are three types of permanent winds. What are they? Trade winds, westerlies, and last one is polar easterlies. Okay. Everybody is clear with this? Okay, we'll study other types of winds also in the same discussion. Land breeze and sea breeze. So just assume this is water and this is land. So in daytime, what happens? Always remember, specific heat capacity of land is less. Specific heat capacity of water is less. That means land always heats up quickly and cools off quickly, whereas water heats slowly and cools also slowly. Cooling is also slow. So this is sea, water, this is land. So in daytime, in the morning when sunrise insolation starts, land heats up quickly. By afternoon, land heats up. So temperature rises. When temperature rises, pressure decreases. So it's a low pressure zone in the daytime on the land. Correct? And in the same daytime, water heats up slowly. So it is still cool because it's heating very slowly. So cool means temperature is low. When temperature is low, pressure is high pressure. So wind blows from high pressure to low pressure. So wind is blowing from sea to land. So this is called sea breeze because the breeze is coming from correct. So at night time, everything reverse. At night time, what happens? Land cools off quickly. So temperature here less. Less temperature means high pressure. So water is still cooling, it is still hot, right? So it means temperature is high, pressure is low, low pressure. Wind blows from high pressure to low. So at night time there is land breeze. That's why many fishermen who do not have mechanized boats, they use night breeze, this land breeze, to get into deeper parts of the ocean and conduct fishing. Okay, so another type of breeze, same concept apply here in the mountain and valley. So this is mountain. Consider this is what? This bare mountain. Always remember, valley is somewhat wetter. There will be rivers, lakes, or whatever. So it is wetter. So in daytime, what happens? This land, I mean, this mountain heats up quickly. Temperature rises. That means pressure decreases, low pressure, and uh, this will be still temperature is less. So there will be high pressure. The wind blows from valley to mountain. It's called valley breeze. Okay. So night time, what happens? In the night time, what happens? In the night time, this cools quickly. So temperature here is less. Pressure is high. So high pressure. And here, temperature still it is more because there is some water content here, right? So temperature is still high. So it should be low pressure. So what happens at night? Wind blows from mountain to the valley. So this is called mountain breeze. This is called katabatic wind. Katabatic wind means what? Mountain breeze. Actually, it drains like river. Early morning, okay. In mountain areas, it drains like river. Okay. So we have completed winds, right? So we'll study cyclones now. How cyclones are created. So there are two types of cyclones. Everybody, focus. Are you here? Who is not following me? Who is not following me? Nobody? Everybody. Following me? Give me some water.
ಸರ್ ನಿಮ್ ಸ್ಕ್ರೀನ್ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಿಮ್ದು ನೀವು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಅದನ್ನ.
ಅವಾಗ ಸ್ವಲ್ಪ ಕ್ಯಾಮ್ರಾ
ಹಾ ಅಷ್ಟೇ ಟಿಲ್ಟ್ ಮಾಡ್ಕೊ. ಎಸ್ ಸರ್.
This geography is so extensive. Other subjects are not like this. Environment, we can go a bit slow. Geography is vast, right? What's the time? 3:15. Okay. Shall we continue for cyclones? Let's create a storm now. Cyclones. So cyclones are of two types. Basically two types. Which are they? Temperate cyclones and tropical cyclones. We will explain all of them. First, we'll take up tropical cyclones. So how cyclones are originated? We'll take example of India here in the Bay of Bengal. Many cyclones do form every year. Correct? So in the month of October, November, when sunrise will be falling over directly here. So cyclones are forming because this is Bay of Bengal. I will explain how cyclones are forming here actually. You know, in this month, October, November, when sunrays will be directly falling more or less here, when temperature rises here, okay, in the water body. So tropical cyclones always occur on the seas, in the seas, where there is vast stretch of ocean water, sea water. Okay, so always tropical cyclones occur in the water bodies like seas. Okay, so it requires large. So a large area of this water heats up. Much area is heating up. It is heating. Temperature is rising more than 27 degrees. How much? More than 27 degrees. Temperature. Just assume it is happening now. Okay. So temperature is rising and temperature has crossed 27 degrees Celsius. Currently temperature is 30 degrees, which is beyond 27 degrees Celsius. So when this entire region heats up, what happens? Always remember, when temperature rises, there develops low pressure. So low pressure has developed now. Why low pressure has developed? Because temperature is. So you know that what happens when low pressure develops? Convection. Always remember, wherever there is low pressure, there is convection. Convection. Okay. So this diverges in northern India, high pressure at that time, because in October, November there is winter. So in northern India there is high pressure, low temperature. When temperature is less, how is it now, Sweta? Can you see? Is camera
Yes,
adjusted properly now?
Yes, sir.
So there is high pressure here in the northern India. Correct? You know, air has risen. You know that air diverges and wherever it it makes descent, there there's high pressure. So wind blows from high pressure to low pressure. Correct? Wind blows from high pressure. From all the direction wind is coming towards, because there is low pressure in the middle. So now take up another here. So here there is low pressure zone. Wind is coming from all directions. There is high pressure, there is high pressure, there is high pressure, there is high pressure. So this is low pressure. Wind is blowing from all directions. Okay, already already you know what is Coriolis force. That's very important. Coriolis force means the force which changes the direction of any moving object, high speed moving object. So wind is a high speed moving object, right? So it's blowing from high pressure to low pressure. As it approaches low pressure, the direction changes because of Coriolis force. How? It will like this, because it's northern hemisphere. For this is right side, right? I told you Coriolis force will be towards right, in the acting towards right in the northern hemisphere. Here also right, from high pressure. For this it is right. Here also it will be right. So what is happening here is the wind is swirling like, correct? Wind is swirling. Why it swirls? Because of Coriolis force. Always remember. Cyclone andre gottalla idea itara ಸುರುಳಿತರ ಸುತ್ತುತ್ತೆ, correct? Why? Because of swirling, because of Coriolis force. Not just swirling, but it is also rising. Why? That's convection. At low pressure there is convection. So it will be more or less this way. There will be low pressure in the middle, and this will be like this. It is swirling and also rising. Swirling because of Coriolis force, rising because of convection. Correct? And there is low pressure. And it is ocean. Ocean means there is enough supply of moisture. Water is there, right? So water is also convecting. When water is convecting, what is happening? It is getting condensed here. So forming one clouds here. There can form one big cloud. This cloud is called cumulonimbus cloud. We will discuss types of clouds also. Cumulonimbus clouds. Cumulonimbus clouds. I will write CN. CN andre ಏನು? Cumulonimbus clouds. These clouds are very dense clouds because they have enough moisture, enough condensation happens, and this is one big monster like cloud which brings heavy rainfall with thunderstorms and high wind speed. Why high wind speed? Because wind is coming from high pressure to low pressure. See, ಇದು low pressure ಎಷ್ಟು ಕಡಿಮೆ low pressure ಆಗುತ್ತೋ ಅಷ್ಟು intensity ಇರುತ್ತೆ. It is like magnet, it attracts winds. If low pressure is too low, so the wind will like rush like anything. Wind speed will be very high, and it's also swirling. This entire system is called cyclone. The exact structure will be like this. Actually, there is one. Okay. Structure will be like this. This is the low pressure, right? In the middle. This region is called I region. And these two walls are called I walls. I walls. So what is happening here is, just remember here, in the I region, wind is rising. Correct? In the I region, wind is convection is happening. The I region. Okay. Once it reaches this upper atmosphere near tropopause, all the moisture it has set. All the moisture it has radiated in the form of cloud. Correct? Correct? Wind is rising and it is radiating in the form of clouds. Once it reaches upper atmosphere, it will become cool. Now it is warm. That's why it is rising. Once it reaches here, it will cool. Once it cools off and it is dry, it will come back. So within this entire this is the one big system is there, right? There is one big cloud, many clouds are there, right? Where wind is rising, but and it is like high speed wind is coming towards it and it is swirling. Can you imagine the destructive nature of this? It is entire system is circulating high speed wind, rainfall, thunderstorms. But in such thunderstorm, there is one area which is very calm. This is exactly at the center. High region is a calm region. High region what? It's a calm region. Always remember, because here wind is not rising up; it is coming back. Correct? Again, it goes up as soon as it reaches here. While going, it will take moisture. It will radiate and form clouds. Again, it will come back. Understanding it? Why it will come back? Because after reaching certain height, it will become dry and cold. Once it is cold, it is heavy, it will come back. By the time it reaches here, again it heats up, it carries moisture and it rises along from I wall. So I wall is the region where there is convection is happening. I is the region where there is descent of the wind. Understanding this? So this width can be around up to 1,200 kilometers. It's not a small area. 1,000 kilometers from here to here. Enter. and this entire system is rotating. Entire system is rotating. Correct? So then here I will draw it like so. There is this cyclone. This is the cyclone. That entire system that I have drawn, right? It is here now. Now it is moving from here to here. That means from which direction to which direction? From east to west. From east to west. Always remember, tropical cyclones move from east to west. Correct? So once it reaches the land somewhere here, that is called landfall. Landfall means it has now entered into the land from oceans. So what happens after it reaches to the landform? So as soon as it reaches here, this area which has received this for the first time, it will receive high rainfall, destructive forces, and it will cause a disaster. We have to manage it. It's a disaster. But after slowly, what happens here? Water supply is not there on the land. Correct? As long as it was there in the ocean, continuous moisture supply was there. But once it reaches the land, the water moisture supply stops. Correct? So that's why it starts becoming weaker, and it will die. Sometimes what can happen is, if there is a small island, like island is this cyclone is here, it is moving from here to east to west. Here it is getting weaker, but already it has caused a lot of damage here. But it is weakening, it is dying because it is now entered into the land. But it is still moving, right? Sulpa, right? So it can cross the island. As soon as it crosses the island, again water supply will be there. It might again get revived. That also can happen. Okay. Next. All of you are following me? Sometimes what happens is this cyclones, instead of reaching here, it will go this way. This is called recurving of cyclones. Why cyclone recurves? Again, due to Coriolis force. You can say recurves towards right. Now apply this Coriolis force to the entire system of cyclone, not just to a particular wind. To entire system of cyclone, apply Coriolis force. Now this entire cyclone system will become one unit. It will recurve. Okay. So recently, what is happening is, usually Bay of Bengal has received highest number of cyclones conventionally. I mean, since a long time. But recently, there is an increasing trend. We see that occurrence of cyclones are increasing in Arabian Sea. Because, first of all, why there are higher cyclones in Bay of Bengal? It is because temperature of Bay of Bengal is higher. Temperature of Bay of Bengal is higher than the Arabian Sea. Always remember. Okay. And temperature here is a little bit lesser. Okay. Yeah. So temperature lesser means, so for cyclones to occur, what is the main requirement? Temperature should be more than 27 degrees. Such temperature is not available here. But due to climate change and all, this Arabian Sea is also heating up due to climate change. So here also we are seeing increasing number of cyclones. So when you please go home and make on the list of recent cyclones, there is a naming system for cyclones also. Okay. So you can just see the recent names of cyclones occurring in Bay of Bengal and Arabian Sea both. So have you understood about tropical cyclones? What you have discussed? Tropical cyclones only. Next we will go to what? Go on to understand temperate cyclones. As the name suggests, temperate cyclones do form where? In the temperate regions. Temperate regions. So temperate region means beyond tropics, right? So 0 degree, 23.5 degree, 23.5 degree. So if the cyclones are occurring here, somewhere around 60 degree, 40 degree, 50 degree, such like cyclones are called temperate cyclones. So the cyclones that we have studied just now is limited to only this tropical region. Let us take up temperate cyclones. So temperate cyclones are the result of something called front. Okay. Before understanding front, we should know what is air mass. So understand what is air mass. What is air mass? Mass of air with homogeneous conditions. Okay, there is one mass of air which has homogeneous conditions, like it has equal temperature. It has equal temperature, equal pressure or humidity, mainly temperature. Okay. And it has common source of origin, like it has originated from the oceans, it has originated from the continents, or it has originated from the high pressure zone, low pressure zones, whatever. So it has common source of origin, number one, correct? And it has almost same conditions, like mainly temperature, correct? So here you already know westerlies. Where are westerlies? So this is 0 ITCZ, right? Pressure belts, talk about ITCZ, and then subtropical high pressure, then subpolar low pressure. So wind goes from high pressure to low pressure, some subtropical high pressure to subpolar low pressure, and the direction is like this. Why it is like this? Because it's a Coriolis force which acts right. So another wind coming from north. What is this wind? Polar westerlies. Correct? Huh? So this is one air mass. This westerlies is what? What is this? This is westerlies. These are polar easterlies. Okay. Polar eastern westerlies. They are meeting along this line. Right or wrong? So two different air masses. This is warm air mass. Warm or cold? Warm, because it is coming from subtropical where temperature is high. This is cold air mass because it is coming from polar where temperature is. It is coming from poles where temperature is very low. This is what? Cold air mass. This is warm air mass. Both of them are meeting at this line. Right or wrong? This meeting line is called front. What is this called? Front. So now I will take up here. So these are westerlies coming from tropics, and this is tropical polar easterlies. This is cold. This is warm. Warm air mass, cold air mass. Two different air masses. Right or wrong? Warm air mass and cold air masses. Different air mass. Two different air masses are meeting at a point called, this line is called front. Now we name these fronts in different ways. It depends on who is approaching who. For example, warm, this cold air mass is still, it is not moving, it is standing still. Cold air mass, it's in high intensity, is hitting cold wind. Then it is called warm front. Okay, what is this called? I will use this triangle to show warm. Okay, take another possibility is that warm air is still, but cold air is coming and hitting this warm air. It can also possible. Then what happens? This forms, I will use this half semicircles. Cold front. Correct? This second possibility. Third possibility is that both are still. So this is like stationary. Okay, we don't say it. Next possibility is both are hitting at equal intensity. Ibru jaga aadtidare. Okay. So Ibru bando dekki. So this creates a front. Okay. Let me tell you. Let me take the first case where warm current is hitting to the. Are you observing, everybody? So warm air mass is hitting to the cold air mass. This cold is always heavy. Cold is strong, right? Cold is heavy always. So what happens when warm air mass hits to the cold air mass? It cannot move it. It is like standing like a stone, right? So what happens? It has to, this warm air mass glides over it and it will rise above. Okay, here it will form stratus clouds and it will form rainfall. Because warm air mass always rises up. Cold is heavy, it cannot move. This is during warm front, there is rainfall. Correct? So let us take another case where cold air is hitting to the warm air. So here what happens? Cold is heavy. When it hits to the warm air, this warm air suddenly rises up. Now cold air replaces warm air here. Now cold air will be here, warm air will be above. So here again, when warm air rises, what happens? Cloud formation, rainfall. Okay. Next, third side possibility is both are hitting each other at the same intensity. At that time, what happens is this cold, both are at equal intensity, right? What happens is there forms a circle like this. This cold wind tries to first press the warm wind to the ground. Then this cold air is following warm wind now, right? Now this is cold and this is warm. Warm air has pushed to the ground now. And again it is pushing the warm air further and it is trying to make a circle here. So here cold air is following the warm air. This is the boundary. Now what happens? This finally warm air will rise and it will form into clouds and fall rainfall. It will create rainfall. So here what is happening is one circulation is happening. Instead of in the cold front, what was happening? Cold wind was hitting to the warm wind and warm wind was rising. That was as simple as that. But in this case where both are hitting at each other, there happens one circle. Okay, one circle happens. Warm wind first goes down and then it has to replaced by the cold wind. Understand this? So this is creating one circle. If there is circulation, that is called cyclone. And this front is called occluded front, where two air masses are hitting at equal speed. This is which front? Occluded front. So in NCERT, you can go and see the exact diagram how it is replacing. Okay, understanding this? So this is how temperate cyclones are formed. So temperate cyclones form, for example, in the Mediterranean region. So this is Italy and Greece, This is Turkey. Okay. So here, for example, here they are forming. They travel towards east. They travel from west to east. Why do they travel from west to east? Not Coriolis first. Why Coriolis? It is because of jet stream. So you don't know what is jet stream. Okay, I should explain what is jet stream. So see here. You know this circulation, right? Everybody? Okay. Already we have discussed this. Okay. No need to repeat it. So here again, high pressure. There is convection. So this is equator. Forget about equator. Just focus here. Subtropical high pressure zone. And this is subpolar low pressure. Here and here. What is happening here is, here there is pressure difference, right? Okay. So this wind wants to move towards north at the upper atmosphere, not in the ground, not near the surface. This is in the upper atmosphere, okay? In the upper, my wind is trying to move from here to here because here temperature is low. Okay. So it wants to move from here to here. But in the higher atmosphere, Coriolis force is always stronger. Always remember, in higher atmosphere, Coriolis force is always stronger because Coriolis force increases with increasing altitude and also increasing latitude. ಮೇಲಕ್ಕೆ ಹೋದಂಗೆ 0 ಡಿಗ್ರಿಯಿಂದ Coriolis force ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಂಡ್ ಸರ್ಫೇಸ್ ಇಂದ ಮೇಲಕ್ಕೆ ಹೋದಂಗೆ Coriolis force ಏನಾಗುತ್ತೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಇವಾಗ ನೋಡಿ ವಿಂಡ್ ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಹೋಗ್ತಾ ಇದೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗ್ಬೇಕು, ಕರೆಕ್ಟಾ? ಬಟ್ Coriolis force ತುಂಬಾ ಸ್ಟ್ರಾಂಗ್ ಇದೆ. Coriolis force ಏನ್ ಮಾಡುತ್ತೆ, ಇಟ್ ವಿಲ್ ಡಿಫ್ಲೆಕ್ಟ್ ದಿಸ್ ವಿಂಡ್ ಟುವರ್ಡ್ಸ್ ರೈಟ್. So now instead of going this side, it will start going this. It wants to go this side, but got deflected towards like this, completely 90 degrees. Why there is so much deflection? Because Coriolis force is strong there. Now this high speed wind, which wants to go towards poles, instead of going there, it is going this way. And it is revolving around the earth at higher atmosphere, like this, circling earth. There is another. So this is high speeding wind. What is this? What is jet stream? High speed wind in the higher atmosphere. High speed in the higher atmosphere. Understanding this? Moving from west to east. So jet stream moves from west to east. Always remember, jet stream moves from west to east. So there are 2 jet streams in the northern hemisphere and 2 jet streams in the southern hemisphere. So just imagine this is a Mediterranean region and India is here. India is here. Okay. So there has occurred cold wind and warm front. Warm westerlies and polar easterlies. They are meeting, occluded front. This is where cyclones are created, right? When they hit, they forms a cyclones, right? So this is what temperate cyclone. This cyclone moves from here to here, west to east, because there is this jet stream. It has influence over this. This jet stream is guiding these winds, these cyclones. Above which there is this jet stream, right? Jet stream is guiding the cyclones, temperate cyclones. So because of that, as the jet stream moves from west to east, even the temperate cyclones also move from west to east. So some of these cyclones also reach India in winter. This is called western disturbance. In India, they are called, remember it, that's important. In India, winter also we receive some rainfall in the northern India, like Punjab, Haryana, UP, Bihar, and sometimes still Assam, sometimes. And mainly in Himalaya, Jammu, Kashmir, we receive snowfall and all. Correct? That is all because the rainfall in northern India in winter, the reason is these cyclones are reaching towards India. Why they are reaching? They're originating here in the Mediterranean Sea, but they are moving towards east. Who is guiding them towards India? Towards east?
Yes.
Just always remember that. So some of the differences you can make out between temperate and tropical cyclones. Tell me, temperate and tropical cyclones. Tropical cyclones, you know, it is forms only on the water. But here there is no such requirement, water or land, wherever. It is just because of meeting of 2 different types of air masses. So it can form both over water and land. Water and land. They move from, temperate cyclone move from
East to west.
west to east. West to east. They move from east to west. Here there is, even in structure, and here these are, rainfall is less here. Rainfall is very less. And here rainfall is very high. In wind speed high. It is because of low pressure, development of low pressure depression. It is because of development of fronts. Due to meeting of 2 different types of air masses. It is here because of development of depression. This is called depression. Depression means a low pressure place, low pressure condition. Correct? And structure also, you know, there is something like fronts and all. There is this occluded front. Here we have eye wall and cumulonimbus clouds here. But here, no such cumulonimbus clouds. Cumulonimbus clouds are bring destructive heavy thunderstorm rainfall. Such rainfall would not occur during, as in temperate cyclones, during temperate cyclones. So that's why in winter, even though rainfall occurs in northern India, you would not see like floods condition and all. Very light rainfall that is good for wheat cultivation. Okay. So we have completed cyclones. Next, rain. We will study something called humidity and all those concepts. Westerlies ಅಂದ್ರೆ ಈ surface winds. Westerlies surface ಮೇಲೆ ಈ ತರ winds blow ಆಗುತ್ತಲ್ವಾ subtropical heat pressure to subpolar low pressure. They blow on surface. Jet stream in the upper atmosphere. High speed wind. So it's different completely. So give me 30 seconds break. So at what time shall we stop? 4:30. So we have to postpone environment then, because it takes another 2-3 hours at least for Indian geography. Right. Indian geography would not take time. These are concepts. In Indian geography, facts. It will take at least 2 hours at least we need for Indian geography. Agila. So what? Tell me that. Huh? Come to the point.
No, very tropical cyclones won't affect the Southeast Asian region.
Why?
No, still.
No, there are many cyclones originating in South China Sea and all. So we have studied as with respect to Bay of Bengal only. In different regions they are called by different names. Okay, that also you should go and study. For example, there are hurricanes in North America. North America means Atlantic Ocean and Pacific, Western Pacific. I mean Eastern Pacific. Correct? In North America they are called hurricane. They are called Willy Willis. Willy Willis in Australia. They are called typhoons in Japan. Tornado is another form. It's a wind, circulating wind can form on land. Same like this, but it's not like cyclones forming on the oceans, in the oceans. Okay, what shall we study now? We will study some about water in different forms, right? In the atmosphere. We haven't studied structure of atmosphere, right? Structure of atmosphere. Fast, you should tell me. There are different layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Within thermosphere, we have ionosphere. From surface up to what kilometers we have troposphere? Average 13 kilometers. Then up to 50. Up to 13 kilometers we have troposphere. Next layer is stratosphere up to 50 kilometers from surface. Then 80 kilometers. What is the next? Mesosphere. Mesosphere, this is stratosphere and troposphere. And next one is thermosphere up to 400 kilometers. Thermosphere. Within thermosphere, we have one layer here. What is called ionosphere. What happens in troposphere? Why do you call it as troposphere? Fast, come on. Why do you call it troposphere? Because rainfall, all atmospheric changes like rainfall, cloud formation, cyclones, etc., occur only here. Troposphere, in the troposphere. Correct? And here temperature. What happens with increasing altitude? Temperature decreases or increases? Generally, it decreases. Okay, that's also important. Remember, in troposphere only, what happens with increasing height? Temperature decreases. Temperature kadme agutte, right? At what rate? 6.5 degrees Celsius per 1 kilometer. 1 kilometer ke 6.5 degrees Celsius kadme agutte. This is called normal lapsing. What is this called? Normal lapsing. This is called normal lapse rate. 6.5 degrees Celsius per kilometer is called normal lapse rate. Correct? Normal lapse rate means decrease in the temperature with increasing height. This is only true in the troposphere, not in other spheres. Understand this? Not in the other layers. Okay. So what happens in the stratosphere? Temperature increases with increasing height. Here temperature increases. Reverse. In troposphere, temperature decreases with height. Here temperature Decreases. Why? Because there is ozone layer. Ozone layer traps UV radiations. When it traps UV radiation, temperature rises. That is why. So you should know the reasons also. Correct? In mesosphere, temperature is very cold. So it is the coldest layer. Temperature is around minus 80 degrees Celsius here. Where? In the mesosphere. Coldest layer of atmosphere is what? Mesosphere. So already I have told you, meteors burn in mesosphere only. Meteors burn in the meteosphere. And so few questions like GK questions they are asked. Where do flights fly? So what is this? This is a troposphere. Troposphere, end of troposphere is called tropopause. End of stratosphere is called stratopause. So above stratopause, flights will fly because that's in the stratosphere. Because there is wind movement will be horizontal. Horizontal means advection. Correct? So they will take support of these winds. That's why flights fly here. It's a calm area. In troposphere, there is a lot of atmospheric activity, right? Convection, rainfall, cloud formation that will disturb the smooth ride of flights. That's why they fly in the stratosphere where it is little smoother. Okay. And mesosphere, thermosphere. In thermosphere, temperature is high. Why there is high temperature even though it is at high altitude? Because solar radiations are observed here, like X-rays, gamma rays, and many harmful UV radiations. Mainly X-rays and gamma rays are observed here. In our solar spectrum, gamma rays, X-rays are observed in the thermosphere. So that layer is ionosphere. That's why temperature is high here. Correct? Why in the stratosphere temperature is? Because UV radiations are observed here. Next radiation will be visible radiations. Visible radiation reach Earth. Remaining high frequency radiations will be absorbed here and here. Here X-rays and gamma rays, here UV radiations. So insolation will be in visible range. Insolation which reaches the Earth is in the visible range. Earth ಆಗ್ತಿದ್ಯಾ? And whatever the Earth radiates back, that will be not albedo. Terrestrial radiation. Whatever the Earth radiates back, you know that, right? Earth, when it receives insolation, this is insolation, where Earth heats up. Earth does not keep this heat forever. Otherwise, since billions of years, Earth would have melted down, right? Earth loses heat also. Every day it loses. As soon as it receives, it also loses in the form of this radiation is called terrestrial radiation. Terrestrial means Earth, radiation emitted by Earth, right? So terrestrial radiation, okay, this is in the form of in the range of infrared. Infrared, this is visible range. When Earth receives, it will be in the visible range. Okay. When Earth radiates back, it will be in the infrared range. So which is more high energy? Which has more higher energy? Which has more energy? Visible range has more energy. So that is why they can easily pass and reach the Earth. Well, going back, this will be trapped by carbon dioxide. Correct? Because it has less energy, higher wavelength and low frequency, infrared radiation. Right? Are you clear, all of you? Okay. So why in ionosphere what happens? They receive, they absorb X-rays and gamma rays. When they receive X-rays and gamma rays, temperature rises. In that high temperature, it will be in plasma state, ionic state. That's why it is ionosphere. Same atoms, oxygen, nitrogen, everything will be there, but in the rare quantity, density is very less. But they are in the form of ions. Why they are in ionic form? Because they are interacting with X-rays and gamma rays, and they are high energy radiations. Everybody is clear with this? Okay. Ionosphere we use for telecommunications, radio communications. Correct? Because when we send radio waves here, radio waves have least energy. They are longer wavelengths, right? So the wavelengths when we send, what happens? When we send this ionosphere, when radio waves we send, it goes to the ionosphere, it will come back. So we use for communication like TV, radio. Radio waves we use. So in radio communications we use ionosphere for communications. Understand this? Because this ionosphere would not allow these radio waves to cross through that, because these radio waves have less energy. Right or wrong? Then all the satellites like low Earth orbit satellites, even International Space Station, they are located in the thermosphere. In the thermosphere, you know that International Space Station, everybody know about it, right? Correct? Okay. So and low Earth orbit satellites also placed in thermosphere. Everybody understood the different layers? And aurora. That also happens in ionosphere, thermosphere only. Aurora means in the polar regions. What happens?
The Earth's solar.
Yes, 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 yes. So let me explain that entire process in briefly. So what is happening here? There is this Earth magnetic field. Correct? Hello, hello. Focus. Earth is like a magnet. Correct? Magnet has this magnetic field. Right or wrong? Okay. So this is solar flares. We already discussed solar flares. They're coming from sun. They come and hit Earth. If we do not have any protection, we all will die. I mean, life will not be there because these are harmful charged particles coming from sun. Understand this? But we have a shield which protects us. That shield is called magnetosphere. This is called magnetosphere, which has magnetic lines. Correct? When this magnetic field of sun and charged particles interact with magnetic field of Earth, what happens? This will prevent the shock. They are coming at high speed, and it is giving that shield protecting us. Right? It is protecting us from it. What happens? It will get cut, starts cutting off. ಇದು ಕಟ್ ಆಗ್ತಾ ಬರುತ್ತೆ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ವೀಕ್ ಆಗ್ತಾ ಬರುತ್ತೆ ಈ ಕಡೆ ಬಟ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಲೆಟ್ ದ ಸೋಲಾರ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಟು ಎಂಟರ್ ಅರ್ತ್ ದಿಸ್ ಸೈಡ್ ಇಟ್ ವಿಲ್ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಸೊ ದಿಸ್ ಸೈಡ್ ದೇ ವಿಲ್ ಫಾರ್ಮ್ ಎ ಟೇಲ್ ಬಿಕಾಸ್ ಇಲ್ಲಿ ಪ್ರಿವೆಂಟ್ ಮಾಡ್ತಿರಲ್ಲ ಅದು ಈ ಕಡೆ ಪುಷ್ ಆಗುತ್ತೆ ದಟ್ಸ್ ವೈ ಇಟ್ ಕ್ರಿಯೇಟ್ಸ್ ಅ ಟೇಲ್ ಆನ್ ದಿ ಅಪೋಸಿಟ್ ಸೈಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದಿಸ್ ಸೊ ಟೇಲ್ is always on the opposite side of the sun. Correct? So what is happening? Another phenomenon is the charged particles coming from the sun. They are guided towards poles. They are guided towards poles. Charged particles are guided towards poles. Correct? Because Earth magnetic sphere is originating from here. Correct? So the charged particles from sun are guiding towards there, towards poles. In the polar region also there is ionosphere. In the ionosphere there are charged particles from Earth. So charged particles of Earth in the ionosphere and the charged particles from the sun interact. When they interact, they give different colors. So it's like light performance, right? This glowing of light in different colors. That is called aurora. What is that called? Aurora. So aurora formation happens in polar regions first of all. In what layer of atmosphere? Thermosphere. In the thermosphere, or you can say ionosphere, which is part of thermosphere. Understanding this? Okay. So I think you have seen in videos and all. So different glow concept, that is aurora. So there are two types of aurora actually. So in the northern hemisphere, like if you go to Norway, Sweden and all, you will see there. Norway is famous, right? So that's called aurora borealis. And there is in the Australia also you can see. That's why you can see in southern hemisphere. Aurora australis. Aurora australis means southern hemisphere. Light display of light in the southern hemisphere is called aurora australis. Display of light in the northern hemisphere is called aurora borealis. Paleomagnetism is as part of seafloor spread theory, probably. These rocks have some magnetic content, like iron, for example, nickel. They record the magnetic direction, right? So sometimes what happens, there is reversal of current. It is north pole and south pole, for example, magnet. Sometimes what can happen is south pole can go there and north pole can come here. This is called magnetic reversal. Okay, whenever the reversal happens, the considered rock particles on Earth, they record this because they arrange these magnetic particles according to the arrangement of these north and south poles, magnetic poles. If the reversal happens, the arrangement of these magnetic particles in the rocks also changes. So they will give history during what time, what type of in what direction our magnetic poles were directed towards. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ನಾರ್ತ್ ಪೋಲ್ ಸೌತ್ ಪೋಲ್ ಇವಾಗ ಚೇಂಜ್ ಆದ್ರೆ ಅರ್ತ್ ಅಲ್ಲಿರುವಂತ ರಾಕ್ಸ್ ಅಲ್ಲಿರುವಂತ ಈ ಮೆಟಾಲಿಕ್ ಕಂಟೆಂಟ್ಸ್ ಇರುತ್ತಲ್ಲ, ಲೈಕ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಇರುವಂತ particles, they also change the orientation. So by studying that, they will understand which direction magnetic pole was there in the past. So that's what paleomagnetism. They study old. Paleo means old magnetism through rocks. Everything, ಯಾವ direction ಇತ್ತು ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. Reversal, we can easily. So as part of seafloor spread theory, you can go and study that Harry has had observed that there were similar magnetic properties on both sides at equal distance. Okay, so that maybe there you have come across that. So what we have to discuss, what we have water in different forms. Okay, so presence of water in the atmosphere is called, that moisture is called humidity. Humidity is of two types. First, absolute humidity and relative humidity. Absolute humidity means total quantity of water present in a definite mass of air. So here these many grams per kg of water, air mass, we say, right? So we mention in terms of grams here. Absolute numbers ಅಲ್ಲಿ mention ಮಾಡ್ತೀವಿ, correct? So I will use another analogy here. Say we have out of 200 you have scored 100. So if I ask you what is your marks, you will say 100 marks, correct? You are telling in exact absolute numbers, 100 marks, that is absolute. If I ask you out of how many you are getting, out of how much marks you are getting 100 marks out of 200, then in percentage if I mention, it will be 50%. Just by hearing 100 marks, I would assume like the marks are 100%, but actually 50%, correct? Out of 200, what is the marks now? 100, it means 50%. In terms of percentage, it is 50%, correct? So this is the difference between absolute humidity and relative humidity. In absolute humidity, we see out of total mass of air, particular mass of air, what is the total quantity, total mass of moisture, water content, that is absolute humidity, correct? Now here we consider, here we mention in grams, just 100 grams, nothing else, correct? But here in relative humidity, out of 200, out of total capacity of that, how much is filled now? Take a bucket, total capacity is 50 liters, but currently on 25 liters is filled. That means 50%. So always remember, relative humidity is expressed in percentage terms, always. Relative humidity, you mentioned percentage. Percentage means we compare something to something. Out of total, what is the present value? Total capacity, ಅಂದ್ರೆ ಎಷ್ಟು mass of air ಇದೆ ಅನ್ಕೊಳ್ಳಿ, ಇದರ capacity ಜಾಸ್ತಿ ಇದೆ, but for now only 50% is filled, water content. Relative humidity is 50%. If total capacity is filled like this, if it is 70%. If 100%, it is completely filled with water. It has no more capacity to hold water. Then it will form cloud. Understand this? When RH is 100%, then it will form cloud. Have you understood the difference between absolute and relative humidity? Okay. Relative humidity is in terms of comparison, total capacity, and what is the total, what is the present mass of water or moisture in the air. Okay. So when this mass of air is completely filled with water, then RH is 100%. Total capacity fill agide anta artha. Then RH is 100%. So at what point? Okay. So this is called saturation. What is this called? Saturation means ನಿಮ್ಗೆ ಆಗ್ತಿದೆ ಇವಾಗ, ಆಗ್ತಿಲ್ಲ ತಾನೆ? So saturation, when no more water can enter into this mass of air. Okay. So this is like completely filled up. Understanding this? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Whatever the capacity, total capacity is there, it is filled up now. No more it is possible for any extra water to enter into this mass of air. Then RH is 100%. That's called saturation. Okay. At what temperature it occurs? It is not always fixed that at particular temperature saturation should occur. That this saturation can occur at any temperature. At what temperature, at this particular time, this saturation is occurring, that is called dew point. So dew point is a temperature, always remember. This point here is temperature at which there is 100% saturation, or at which there is saturation, at which RH is 100%. RH is 100% means total capacity is filled. That is called saturation. Understanding this? RH 100% means saturation. At what temperature this is happening? That is called dew point. Usually that is low temperature, right? At low temperature only that capacity will get reduced. At high temperature, what happens? This mass of air expands. Everybody focus here. What happens if temperature rises? If temperature rises, what happens? Total capacity will increase, right? Total capacity will increase now. Then RH will come down because capacity has increased. Correct? Mass, total mass ಜಾಸ್ತಿ ಆದ್ರೆ percentage ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತಲ್ವಾ? Instead of 200, if you keep 400, it will be for same 100 marks, it will 25% only. Like that. Total capacity is increased because of increase in temperature. Understanding? So that has reduced the RH value. Correct? So at that time, dew point will be further down. Temperature should be further decreased, then it will be dew point. Dew point means at what temperature this mass of air is completely getting filled with water. If you are clear with this, let me explain few more words. Like there is something called latent heat of vaporization. At what temperature water in liquid form will convert into gaseous form. Correct? Lake alli, oceans alli water liquid in the gases convert agutala when temperature falls on this. I mean when sunrise falls on this. Okay, so this is called latent heat of vaporization. At what temperature this is happening, that's called latent heat of vaporization. And when it rises, it will get, what is this called? What is this called? Evaporation. Evaporation and convection. This is evaporation and convection, right? At upper atmosphere, what happens? It will shed the moisture, right? Temperature, what is happening here? Decreasing. When temperature decreases, then the capacity also start decreasing. Temperature just expand agutte, but ಮೇಲೆ temperature ಕಡಿಮೆ ಆಗ್ತಿದ್ರೆ it will start condensing. Then whatever the water is there, it will get condensed. Then RH will be 100%. Correct? 200 in the 100 ಬರುತ್ತೆ capacity, total capacity 100% reach ಆಗುತ್ತೆ. Correct? So then condensation happens. Dew point, that will be at what temperature it happens, it's called dew point. Then cloud formation happens. After that, it will be come in the form of rainfall. It will come in the form of rainfall. Everybody understood this? Okay. Next, we will study this condensation. This condensation can happen due to what reasons? Decrease in temperature or decrease in volume. Volume kadme adru kuda volume decrease agtide. Then also condensation can happen, right? Condensation means saturation reach agutte, right? When volume also decreases, then also condensation can happen. When both temperature decrease in temperature and volume together, if they play out, then also condensation can happen at higher rate. Understanding this? So for condensation to happen, what should happen with respect to temperature? Temperature should increase or decrease? Decrease. What about volume? Volume should also decrease because total capacity decreases. Here also total capacity decreases. So condensation can happen anywhere. Remember, not only in the higher atmosphere, it can happen also in the lower atmosphere. So it can happen in different forms. Different forms of it can be dew formation, not dew point, this is dew, or frost, or fog, or mist. Both are more or less same. Or clouds. Okay. So all of these are results of condensation at dew point. Artha agtidiya? All of these are results of condensation at dew point where RH is 100%. Okay. So this happens at different places in different ways. So we should understand the difference. So dew yaವಾಗ form ಆಗುತ್ತೆ? So dew is that dew and frost we should study together. Dew and frost are forming at the surface, near the surface, not in the upper atmosphere like clouds. This is happening near the surface. So when the air which has higher moisture content, for it it comes across, it hits and it deposits that. If the condensation happens on solid surfaces, like there is a stone here, on this stone the air carrying moisture hits this and condensation is happening over this. For example, there is a rock, then it will form like a raindrops, not raindrops, drops of water. These drops of water on leaves, stones and glasses. Correct? Winter time ನೋಡಿದಾರಲ್ವಾ, ಗ್ಲಾಸ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಫುಲ್ ಚಳಿ ಇದ್ರೆ ವಾಟರ್ ಡ್ರಾಪ್ಲೆಟ್ ಡೆಪಾಸಿಟ್ ಆಗಿರುತ್ತೆ ಕಾರ್ ಮೇಲೆ, ಗ್ಲಾಸಸ್ ಮೇಲೆಲ್ಲ, ರೈಟ್? ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಡ್ಯೂ. Dew is nothing but condensation near the ground, near the surface. Correct? Instead of upper atmosphere, it is happening near the surface, and it is happening when the air is coming across the solid surfaces. Always solid surfaces. Okay. Same thing. Instead of dew, it can be frost. So frost can happen in USA, Europe, and such countries. Very common. And for agriculture, it's a big issue there. Frost. In agriculture, crops are also solid bodies, right? So what happens? Same thing is happening, but here instead of water drops, ice flakes are ice are deposited. Instead of water, land deposit agutta ice. Water badlu ice adre, that is called frost. Why it is happening? Because condensation is happening. Condensation happening because temperature is low. In winter only it happens. Correct? Because in winter near the surface also temperature is so low that dew point can be reached. When dew point is reached, condensation happens, clouds and all of that. Okay. So dew or frost. Understood the difference? One more difference is dew is formed when dew point is above 0 degrees Celsius. When condensation happens above 0 degree Celsius, water droplets are formed, dew is formed. When same condensation or dew point is below 0 degree Celsius, frost is formed. Correct? Sub 0 degree Celsius ಇದ್ರೆ ಅದನ್ನ frost ಅಂತ ಕರೀತೀವಿ. Clear, everybody? Then fog. Fog is nothing but cloud. Exactly cloud. No difference at all. Only difference is height. Cloud upper atmosphere ಆಗುತ್ತೆ, fog lower atmosphere ಆಗುತ್ತೆ. So fog ಏನ್ ಬೇಕಂದ್ರೆ dust ಬೇಕು, ಒಂದು dust particle ಬೇಕು. Okay, around this dust particle, this water condensation happens. Then it is called fog. Same fog iladre, that is cloud. There also we need this dust particle. This is called hygroscopic material. Hygroscopic dust particle. Hygroscopic means something which attracts water. Hygro means water. Hygroscopic dust particles. Okay. So for cloud formation and fog formation, what do we need? Hygroscopic dust particle. So it is different from fog and mist. Fog and it is different from dew and frost. How? Here it is condensation happening around dust particle in the open atmosphere, and the dew and frost are forming on the solid surfaces. Correct? Here it is in the open atmosphere, just utilizing these dust particles. That's all. And if the fog is too dense, then it is called mist. Usually mist you will see in mountain areas where there is dense fog. The dense fog is called mist. That's all. And clouds. Cloud formation same like fog formation but in the higher atmosphere. Now we study different types of clouds. There are different types of clouds. What are the different types of clouds? So first understand basic clouds, then combination is very easy. Cirrus clouds. So go from the surface, higher clouds are called. So if it is around 8 to 12 kilometers above, full height gap, correct? Then they are called cirrus clouds. They are like feathers usually, correct? Feathers are white. They are always white in color. They are always white in color. They do not bring any rainfall. Remember. So first type of clouds are called cirrus clouds. Okay. Next, another type of clouds are called cumulus. Wherever they are, cumulus clouds means they have flat base and they have cotton wool tara irutte. Looks like cotton wool. Like, okay. Can you imagine the normal cloud hinge draw ಮಾಡ್ತೀವಿ, right? So that your conventional drawing of cloud is what? Cumulus clouds. Okay. Okay. Next, another type of cloud is what? Stratus. Stratus means they are like flat. Either layer tar idre, that is stratus at any height. And another type of clouds are nimbus. Nimbus means dark. If it is dark cloud, then male mode. Yes. If it is dark cloud, it is nimbus. Dark idaga ಏನಾಗುತ್ತೆ, dense ಇರುತ್ತೆ. Dense ಇದ್ದಾಗ ಮಳೆ ಆಗುತ್ತೆ. So only nimbus clouds can bring rainfall. Remember. Correct? Full white clouds idre male baruta? Baralla. They cannot bring rainfall. Nimbus clouds only bring rainfall among all of these. Understanding? So 4 basic clouds what we have studied. Cirrus. Cirrus means high clouds. Stratus means flat clouds. Correct? Next, another type cloud. Cumulus. Cotton wool. Next, 4 type is what? Nimbus. Nimbus is dark cloud. So next, combine all of them and we will study different clouds. Cirrus. So now there is something called cirrocumulus. Cirrocumulus ಅಂದ್ರೆ ಹೆಂಗಿರುತ್ತೆ? Cirro means higher altitude. At this height. Cumulus means same water, but they are at higher altitude. That's all. Male ಎತ್ತರಕ್ಕಿದಾವೆ. Correct? Cirrostratus. Cirrostratus means they are stratus clouds, but where they are higher altitude. At this altitude, 8 to 12. Next, ಮಾಮೂಲಿ cirrus ಅಂತ ಅಂದ್ರೆ they are like feather like. Already ಹೇಳಿದ್ನಲ್ಲ, feather like white color. All of them are white color. So all of these do not bring rainfall. Next, alto means middle height. Always remember, alto means middle height. In middle height, there is alto stratus. This is stratus cloud, same like this, but this is cirrus because it's a height. So this is 4 to 8 kilometers. 4 to 8 kilometers. So this is alto stratus and alto cumulus. Correct? Because alto means middle height, 4 to 8 kilometers. Cumulus, right? Next, just stratus anta bandre usually they are near the surface. Just only stratus anta bandre near the surface. Stratocumulus ಈ ತರ ಇರುತ್ತೆ, ಆತರ ಈ ತರ ಇರುತ್ತೆ. ಸ್ಟ್ರಾಟಸ್ ಇರುತ್ತೆ, ಮೇಲೆ cumulus ಇದೆ, ಎರಡು ಇದೆ. ಕರೆಕ್ಟಾ? Stratocumulus, just combination. If they are dark, they are called nimbostratus. If they are dark, nimbostratus. Or if they are dark and cumulus, nimbocumulus. Usually cumulonimbus. They are like big clouds. Cyclones formal ಹೇಳಿದ್ನಲ್ಲ, they are cumulonimbus. their height starts from here, near the last type of cloud, what we are discussing, cumulonimbus. They are very important ones. What is that? Cumulonimbus. Nimbus means dark clouds. Cumulo means cumulus clouds. Usually cumulonimbus clouds are starting from 1 kilometer near the surface. In the 1 kilometer start up to cirrus clouds complete one day cloud. This big cloud. Can you imagine it's dense? Condensation agide. How much rainfall it can bring in this region? Correct? So in equatorial regions, every day cumulonimbus cloud is forming. Equator regions, because there is everyday high rainfall, everyday high precipitation, everyday high convection, everyday high precipitation. Correct? Precipitation means rainfall, where cumulonimbus clouds are forming in the equatorial region. So cumulonimbus clouds are formed at around, in the equatorial region and cyclones, these two regions. Okay, cyclonic regions. Have you understood this, all of you? Cumulonimbus clouds is special one. Nimbus means rain bearing clouds. Next, cloud formation. This cloud will fall down, right? Basically it falls down. That falling down is called precipitation. Falling of cloud is called precipitation. It can fall in different forms. Sometimes what happens? Rainfall is the most common one. Correct? So what we are studying now? Precipitation. So precipitation can be precipitation can be in the form of rainfall, where the cloud is falling in the form of water drops, rainfall. Correct? So that you already know. Why rainfall occurs is, here. What is happening here? There is a cloud here. Okay, it is bringing rainfall. How it brings rainfall? Assume it is dropping as a raindrop, or it can also drop as a snow flakes. Okay. But as it comes down, temperature, what happens to temperature? Temperature increases or decreases? Temperature increases as we come down, because as you go up, temperature increases. As you come down, temperature as you go up, temperature decreases. As you come down, temperature, sorry for that. Okay, temperature increases. When temperature increases, these ice crystals will convert into water droplets to fall in the form of rainfall. So generally, this is the case everywhere. Everywhere, temperature increases with decreasing height. That's why rainfall occurs. So maximum precipitation will be in the form of rainfall. But other forms of precipitation will be snowfall. Correct? Snowfall, consider this is in Himalayas, higher altitude or higher latitude, where temperature is less, where temperature is not increasing with height, with decreasing height. Generally, what happens with decreasing height, temperature increases. But in this case, temperature is still low. That's why the snow, that's ice, will not convert into rainfall. So it will form in the form of these hexagonal crystals called snowflakes. Okay. So in Jammu Kashmir in winter times, we can see that temperature is very low. That's why that it will not give a chance for that ice crystals to convert into water droplets. So it will form in the form of snowfall. Another yes, freezing point is there. Yes, below 0 degrees is there snowfall. Another type is what means hailstones gotalva. So hailstones are like circularly arranged ice, again directly falling from the clouds. They're solid ice. Correct? In Kannada we say anekalu. Correct? Anekal belutalva. So that is what hailstones, that you know. Now what is important is sleet. So sleet is happening. Just observe this. One sleet formation occurs in mountain valleys. So in mountain valleys, just now I studied katabatic wind or mountain breeze. Here cold wind is coming from the mountain and depositing near the valleys. So now there is cold wind here. Assume there is cold wind. There is warm wind there. Again there is warm wind. Okay. Again there is cold wind, because with increasing height temperature decreases. But here there is cold wind. Cold wind is deposited because the cold wind is at night is blowing from mountain to valleys. Now assume there is rainfall. Okay, there is rainfall. First of all, there is cold, so it will be solid crystals, right? Solid crystals. Once warm area is reached, it will convert into water drops. Water drops. But once again it reaching this cold zone, then it will again convert into ice crystals. This is called sleet. Sleet means refrozen raindrops. Raindrops are getting refrozen. Refrozen raindrops are called sleets. So this is one region where sleets are commonly occurred, mountain valleys. So this is different types of precipitation and different types of rainfall also is there. For example, convectional rainfall. Normally ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋತೀವಿ ಅಲ್ವಾ, there is insolation, land heats up and here water body evaporates, convection happens, cloud condensation, cloud. This is what convection rainfall, where there is convection. Okay, sometimes what happens, rainfall can occur also due to rainfall, this presence of mountains. So take Western Ghats is the best example. This is Arabian Sea, southwest monsoon is coming and hitting to the Western Ghats. Here these rain bearing winds are gliding through the mountains and rising above, where they condense and they bring rainfall. Here rainfall is occurring not due to convection, because of the presence of mountains. Here rainfall is occurring not because of convection here, but because of the presence of mountains. These are called orographic rainfalls. The foothills of Himalayas also rainfall is in good amount. That is why there are moist deciduous forest. Correct. That is also because of orographic rainfall. And another type is frontal precipitation that we have just discussed. Warm front, cold front hitting together. Right. There is always warm air is rising above and it is bringing rainfall. That is another type. So frontal precipitation, frontal rainfall, orographic rainfall, and third one is what? Convection rainfall. Okay. ಏನು ನೋಡ್ಕೊಂತು ಓಷನೋಗ್ರಫಿ ಹೇಳೋಣ ಅದು local winds. So local is what? It's a local wind forming in the summer season in North India. Okay. So isotherms ಬಗ್ಗೆ ಹೇಳ್ಬೇಕಂದ್ರೆ isotherms ಅಂದ್ರೆ ಏನು? The lines, it's a line joining equal temperatures. Here it is 25 degrees Celsius. Here it is 25 degrees Celsius. Here it is 25 degrees Celsius. Okay. So then you join this line and this area join. This area join. Okay. So then this line is what is called isotherm. So isotherm means a line which is joining equal temperatures, same temperatures. Okay. And isobar means same line joining which have equal pressure. Okay. So you have to study this deviations. For exams, you should know few points regarding this. How they get deviated in different seasons. Say in summer, in northern hemisphere, in July there is summer in the northern hemisphere. Right or wrong? In July there is summer in the northern hemisphere. Correct? Because around June, July there is sun will be in the northern hemisphere. Correct?
Yes, sir.
So this is land. Any land you can take, Europe or whatever. I'll just take this square for conceptual understanding. Okay. Isotherms, how they will be? They will ask this question. So land in summer land heats up quickly, right or wrong? So assume temperature will be more on land or water. Here and here, this is water. Okay, this is land. This is again water. This is so temperature, say any degree, say 27 degrees Celsius on the land. At the same latitude, what will be the temperature? Will be more than 27 degrees Celsius. Same latitude. Okay, we are considering the same latitude. At the same latitude, what will be the temperature in the water?
Lesser than the land.
Lesser than the land. So it will be 25 degrees. That means 27 degrees Celsius will be where? Above this or below this in the water. You want to find another 27 degrees because we have to join lines having equal temperatures. So we have to, so there is again 27 degrees Celsius. Okay. But what in the water body? 27 degrees Celsius will be above this or below this? Below, because more towards equator it will be higher temperature. Correct? At this zone it is 30 degrees Celsius here, but it is 27 degrees Celsius. Correct? Because in the summer land heats up more quickly and the higher temperature would be on land than the oceans. So again, this is 27 degrees Celsius. Right? Now join the places of equal temperature. What is that called? Isotherm. Okay. So what is happening here is these isotherms are deviating towards poles or higher latitudes on the land in summer. So in exam, if you get confused, just give 15 seconds. Calmly, you just draw somewhere and you can get to it. Just if you know the basic concepts, you can get to it for any question. So in summer in the northern hemisphere, the isotherms deviate to north toward poles on the land, but towards equator in the waters, ocean bodies, water bodies. Okay. So again, you give me any context, I will tell you. Okay. Just with the same understanding. Yes. Yes. So you know that northern hemisphere has more land. Southern hemisphere is more or less ocean. More or less ocean. There is some land like southern part of extreme part of Africa and South America and Australia. Okay. Otherwise, this is completely ocean. Southern hemisphere and northern hemisphere, Indian Ocean is not there. In northern hemisphere, Indian Ocean is only half. In the southern hemisphere, it is there, but in the northern hemisphere, Indian Ocean is not there. Correct? So northern hemisphere is more or less more land. It has more land. That is why you will see these deviations. When you enter the land, there will be more deviation. But in the southern hemisphere, more or less same, right? So that is why more or less straight lines will observe in the southern hemisphere because of distribution of land. Okay, there is no land. There is no much deviation in the distribution of land and water. Okay, so like that you can imagine anything, right? I mean, you can arrive at any answer, but you can give me another context. Say in winter in the northern hemisphere. In winter, what will be the condition? This is land and this is water. Okay, so what happens on the land? Temperature here is say in winter temperature will be more in the sea. See here it is 20 degrees and here it will be cold 17 or 18. Okay, so next. So what is happening here? 17 degree will be, 20 degree will be here. Correct? So what is happening? 20 degree will be in the upper side in the oceans in winter. So in winter, these isotherms deviate towards north in the oceans, especially in the North Atlantic Ocean. This is more prominent. There is another region in the North Atlantic region that's special. Okay, don't get confused. In the North Atlantic, remember as a special case. In the North Atlantic, there is a ocean current that is called North Atlantic Drift, correct? Or Gulf Stream. We will discuss it again. It's like river. One river is flowing here. You know that, right? Ocean currents, you know. So this ocean current is here called North Atlantic Drift. It carries warm water towards poles till Norway, near polar circle. So that is why isotherms here temperature will be high, even though it is at higher latitude. That's why isotherms deviate towards north here. So you can go and check this diagram in the NCERT. They have given this. Here there will be more deviation in the Atlantic Ocean only. Why there is more deviation in Atlantic Ocean? Because warmer water is reaching towards higher latitudes because of this current. Clear? Next, we will start with oceanography. Fast. We'll finish oceanography quickly. Huh? No. Saturation ಆಗಿದೆಯಾ? RH is 100%. So we'll finish oceanography. No, then it's not usual class. We have to strictly. I'll take.
Yes, sir.
Alright. Let's listen for 5-10 minutes. Okay. So it's not even 4:30. Come on. Boring. Huh? Boring is that. I mean, but we have. So tomorrow we have to do again geography. So then environment will be postponed. Okay. Geography is such a subject.
ಈಗ ಪಾಠ ಮಾಡಿದ್ರೆ
I mean, there's no fixed source. I referred many. I mean, I'm doing it for a long time now. So
what's this year?
yes. See you guys tomorrow. Again, 11 o'clock we'll have geography. Environment will be postponed.